Hi everyone, in this video we will talk about TCP connections, how to establish a connection and how to terminate a connections, and we will take some examples of how the data transfer is happening. So we will talk about all these things in this video. Now there are two entities, one is client and another one is server. I'm calling one entity client, another entity server because client is someone who basically initiate the connection. Although the data transfer is in both the directions, which means the client also sends the data and server also sends the data. So TCP is full duplex, which means the data transfer is in the both directions. But I am calling one of the entity as client because this is someone who is initiating the connection. Okay, and server is someone who is not initiating the connection. Basically server is generally like servers of like Google server or some company servers, and client is generally host our PC. So basically we send some data to the server because we want to initiate the connection, not server. Like we are in the need of initiating the connection, not server in the need is in the need of initiating the connection. So we initiate some connection. Suppose I want to sort some data, then what I will do, I will take my array, I will send this array to the server, and let's suppose this array is too big, which means that my machine is not able to process this data. So I will do what, I will send this data to the server. Then I am doing what, I am doing the data transfer, right? So this is the data transfer from client side. And once the server sorts it, so server can sort it because server is a high computing machine, and server can sort this data. When the server sorts it, then server will send the sorted data back. So server is doing what, server is also doing the data transfer. So the data transfer is having in both direction, but client is someone who is initiating the data transfer or initiating the connection. That's why I'm calling it as a client. So the terminology is clear. I hope there is something that is called client and server. Client is someone who is initiating the connection. Server is someone who is actively listening to any of the client who wants to initiate the connection. So let's first talk about how to establish a connection. Now suppose a process is running in one host, and let's call this host as a client that wants to initiate a connection with another process in another host. Let's call it server. The client application process first inform the client TCP that it wants to establish a connection to a process in the server. So client in the client also you have a transport layer and application layer. So let me just do one thing. Let me just show both of them. Let's say this is the client, and then this is the process or this is the application layer, which will ask the transport layer. This is the transport layer, which will ask the transport layer to initiate some connection. So based on that, based on the request, client will send the connection establishment request to the server. This is what is happening, right? And each party must initialize communication and get approval from other party before the data is transferred. So either client is sending the data or the server is sending the data. Both party must agree that the other party is ready to accept the data. Which means if client wants to send the data, then client will ask to the server that, see, I want to send some data, can you accept it? So this is the first message, which is called connection establishment message or SYN packet. So I will talk about it in this video. But this is the first message. The client is asking to the server that, okay, I want to send some data. Then server will say that, okay, I have accepted your request, and I also want to send some data in the reply because this is full duplex, right? Then client will say that, okay, I have accepted your request. So first message is there, I want to send data. Second message says that, okay, I also want to send the data. Want to send data. And third message says, okay, which means that both parties are agreeing that other party can send the data, right? It's not like only client or server is agreeing that other party can send the data. So both parties is requesting that they want to send the data, and both parties are agreeing that, okay, other party can send the data. Now this happens in three phases, which means suppose you want to send or client want to send some data to the server, or client want to establish some connection to the server. Then this happens in three phases. This is client, this is server. So client will say see, I want to send some data, or I want to establish some connection. So client will set one of the flag in the TCP header, which is a SYN flag, to 1. Client will say that okay, this is a SYN packet. So from each side, if this is the first packet, then the SYN flag will be set. Otherwise, SYN flag will not be set. So if SYN flag is set, then it means it should be the first packet from each side. Now this packet means that client is telling to the server that, see, this is my first packet and I want to establish some connection with you. Now what do you think? Client should send the data with this packet or not? Client should not send the data with this packet. It's just a control packet. We call it control packet. Control packet. It's just a control packet where client wants to just request. Now server may accept or may deny. So let's suppose the server is accepting, and server will say that okay, which means server is acknowledging this packet. So it will say that okay, ACK is 1 and there will be some acknowledgement number, right? So suppose this sequence number is X, so this packet will contain some sequence number which is having just 1 byte. That 1 byte is useless. Basically this byte could be anything, all zeros, all ones, could be anything, some random number. But this 1 byte is this is containing 1 byte, and suppose that byte number is X, so the sequence number for this packet will be X, right? Now this will say that okay, acknowledgement field is valid. ACK equal to 1 means acknowledgement field is valid, and acknowledgement number, now ACK number will be X plus 1, which means now I'm expecting you to send X plus 1 as a sequence number. This is the acknowledgement packet that server is saying. Now server will also say, at the same time, server will also say that, see, that is okay, but I also want to send some data. So let the SYN flag to be 1, because this is the first packet from my side. This is the first packet from my side, and I want to also establish a connection. And then client will say that okay, which means client will say, suppose this is the sequence number of Y, then client will say that okay, which means ACK number is Y plus 1, and ACK is basically valid. I mean ACK has to be valid, then only ACK number makes sense. I hope you got it. So let me just repeat it. Client will say that I want to establish some connection, that's why this is the first packet, so client will say SYN equal to 1. This is the first packet from the server, so it will say SYN equal to 1. Now since this packet has to be acknowledged, that's why it should contain some sequence number so that it can be acknowledged. That is why it should contain at least 1 byte. That byte is imaginary, which means that byte is useless, but it should contain 1 byte so that it can have the sequence number. And this byte will be acknowledged by the server. So server is saying that now acknowledgement number is X plus 1. So basically this is the first packet which consumes 1 byte or 1 sequence number. The first packet, or let me just call it SYN packet. This is called SYN packet. This is called SYN plus ACK packet because I'm sending SYN and ACK. This is called ACK packet. So let me call it SYN packet. This SYN packet consumes 1 sequence number, right? SYN packet consumes 1 sequence number, which means that SYN packet has to be acknowledged, so that like if SYN packet has to be acknowledged, then it has to consume 1 sequence number, right? So that the server can send the acknowledgement. Now server will also say that, see, this is the first packet from my side and I also want to send some data, so let this SYN to be 1 from my side, right? So it will say that SYN is equal to 1, and since this packet also has to be acknowledged, that's why it should be consuming 1 sequence number, right? So it should also be consuming 1 sequence number. So it will say that okay, let me consume 1 sequence number. So the next sequence number that client will accept is Y plus 1. So this is SYN plus ACK packet. SYN plus ACK consumes 1 sequence number. Why? Because it also has to be acknowledged, right? It also has to be acknowledged, that's why it consumes 1 sequence number. Now it is basically dual purpose. It is also acknowledging the previous message and also saying that I want to also send the data, because TCP is full duplex. Now client will say that okay, which means client will acknowledge the previous packet. Since it is just an acknowledgement, it is not containing any data, so it will not consume any sequence number. This packet ACK, this is just called ACK packet, will not consume any sequence number, right? I hope that is clear. Now this last packet may have the data, If it is having the data, then it will consume the sequence number. Suppose it is also having some data, acknowledgement is okay, but apart from acknowledgement it is also having some data, that is called piggyback acknowledgement, right, if you remember. So if it is a piggyback acknowledgement, then obviously it will consume some sequence number based on the data length. Suppose that the data is 500 bytes, then it will then first let's suppose the first byte has to be x plus 1 because it is waiting for x plus 1, and then the last byte should be some x plus 500, something like that. Then it will consume 500 sequence numbers, right? So ACK will not consume any sequence number if it is not containing the data, right? So you can write here, if it is not containing the data, it does not contain data, right? So this whole procedure is called connection establishment phase. See here, there is a client that sends some SYN packet, there will be SYN plus ACK and then ACK packet. Now, one thing is to note here is that whenever you are sending ACK packet, then you are also advertising your window, which means to say that if this ACK is 1, then I am expecting some acknowledgement. I mean, I am expecting some number of bytes from the other party, which is in this case, let's suppose this ACK is 1, then in this case the acknowledgement number is 8001. So I am expecting the next byte to be 8001. That is particularly clear, right? Now it also means that, see, if I am expecting something, then this is my window size, which means you should send something that start with 8001, but you should not exceed this window size. This window size only makes sense whenever the ACK is 1. This should be clear to everyone. Why? Because if ACK is 1, then only I am saying that I am expecting something, and then only I will advertise my window. So in this case, when you have the first packet where your acknowledgement is not 1, which means acknowledgement is 0, which means acknowledgement is not valid. So this particular packet is not saying that it is expecting something, right? This particular packet is just saying that, okay, let me just first establish this connection, and then the server will reply. Server will say that, okay, now I'm expecting the byte that should start from 8001, and this is my window size. As per my receiver, if you consider me as a receiver, so both are sender and receiver because TCP is full duplex, so you will be having a sender window here, also the receiver window. So it says that as per my receiver window is concerned, then I have the window size of 5000, which may mean that the allocated buffer may be more than 5000, but I just have 5000 bytes from the receiver, right? And now the client will say that, okay, let's just acknowledge it. So client will say that, okay, now I am expecting something that start with 15001 and my window size is 10000. So whenever this acknowledgement is 1, then also I am also advertising the window size, that is receiver window size. And that's how we do the connection establishment phase. This whole process is called connection establishment. Why? Because these are the first sequence of packet that the client and server are sending to establish the connection. Now, there are three things, just to repeat. Like, there are three packets. One is SYN packet, another one is SYN plus ACK packet, third is ACK packet. As I told you previously, that the SYN packet does not carry any data, but it consumes one sequence number. Now, can you answer me why it consumes one sequence number? Because it has to be acknowledged, right? But it consumes one sequence number. Why? Because it has to be acknowledged. I have already written this here. See, consumes one sequence number because it has to be acknowledged. So let me write it there itself. Because it has to be ACKed, which means acknowledged. That's why it consumes one sequence number. Now this SYN plus ACK cannot contain data because this is the first packet from the server. So server cannot directly send the data. It first needs to ask for the client whether it can send the data. So that's why it is sending the SYN. And ACK is just to acknowledge the previous SYN. So this SYN plus ACK cannot contain any data, but it consumes one sequence number. Why? Because this also has to be acknowledged, right? That's why it has to consume one sequence number. Now last packet is ACK packet. It may carry data, it may not carry data. If it is carrying data, then it is called piggybacked acknowledgement. If it is not carrying the data, then it is just an acknowledgement. So if it carries data, then it consumes sequence number. If it does not carry data, then it does not consume any sequence number. So I hope this is clear. And like, what do I mean by consuming a sequence number is that if I am saying the sequence number is X, now I cannot again use the sequence number X, which means now I will be using sequence number which is X plus 1 if I am only consuming one sequence number. See here, If I'm saying the sequence number is 8000, and since this 8000 has been consumed, that's why I'm saying in the next packet the sequence number is 8001. This is what I meant by saying that I'm consuming one sequence number, or this packet is consuming one sequence number. So I hope these 3 points are clear. Now let's move to the next phase, which is connection termination phase. And most implementation today allow two type of connection termination. One is called three-way handshaking and another is called four-way handshaking. So we will look at both of them. But before that, I have a question. The question is that why we do not have only two-way handshake in the connection establishment phase, which means why we do not just say that okay, the client wants to send some data, so this is SYN, and why it is not just ACK, and why I'm not calling it connection establishment phase, right? Which means why I'm not saying it two-way, and why I'm saying this three-way, which means this SYN, then SYN plus ACK, then ACK. Why that is the case? Because TCP is full duplex. So even though the server does not have the data to send, but the TCP allows it to, or in some sense, like force it to send the SYN plus ACK packet instead of just saying the SYN packet. So instead of just saying the ACK packet. So the first packet from every, either it is client or server, from every of the host, it should be having SYN packet. It may contain the acknowledgement or may not contain the acknowledgement, but the first packet has to be SYN packet. So first packet from the client is SYN, first packet from the server is also SYN. If it is containing the acknowledgement, then this is SYN plus ACK, because this is the connection establishment phase. That's why it is SYN plus ACK. I hope you got it. So the first packet has to be SYN. That's why it is not two-way, it is three-way. That was my first question. Now I have another question. Another question is very interesting, and you may find it a bit confusing also. So my question is that TCP is reliable protocol, right? And TCP is connection oriented, reliable, everything is there in the TCP. And IP is unreliable protocol. Now my question is that how can TCP be a reliable protocol who is using the service of IP, which is itself is unreliable protocol? So let me write the question. How can TCP be reliable protocol which is using service of IP, and IP by itself, which is by itself is unreliable protocol? So this question may confuse you, but answer is very simple. Answer of this question is that TCP guarantees the reliable end-to-end reliability, which means that at the host, at the process level, or at the port level, it is guaranteeing that the reliability, it is guaranteeing that data is reliable, which means it does not care at the network layer part, which means at the network layer you may be having out of order data, you may be having unreliable data, which means the data may be having some error because IP do not have flow control, error control, anything. So there may be some missing packets here in the IP layer. But whenever it is delivering to the transport layer, now transport layer will deliver these packets to the application layer only when the packets are in order. I mean, if you are using the TCP service, then the packets are in order, there is no error in the packets, there is a flow control, there is error control, everything is in order. So basically transport layer to application layer, this is the reliability that transport layer is providing. But since IP is not providing the reliability to the transport layer, so this is okay, which means network layer may send out of order packet, may send some packets which are having some errors, so that is okay. But it will store those packets, if those are out of order packets, it will store those packets here at the transport layer itself, but it will deliver those packets to the application layer only when the packets are in order or packets do not have any error. So the reliability is at the transport layer, which TCP is providing. So do not get confused with this sentence, that how can TCP be a reliable protocol which is using a service of IP, which itself is unreliable. So which means IP is unreliable, that is okay, but this unreliability is just till the network layer, which means whenever transport layer is transferring the data to the application layer, then the data is reliable. So that's what I meant here. Okay, now let's move to the connection termination phase. So connection termination is offered in two ways. One is three-way handshaking, another is four-way handshaking. Actually, both are almost same. Just one packet in the three-way handshaking got divided into two packets. So let me talk about both of these methods. Let's first talk about the three-way handshaking. Three-way. So it is very simple, which means suppose this is client and this is server. Now client wants to, let's suppose, terminate the connection because now job that client wants to do from the server has been done, suppose. Then client will send one packet which is called fin packet, which means it wants to terminate the connection. And server may say, if it is three-way, then server may say, or like, I mean, in general, server may say that it also wants to send, it also wants to basically terminate the connection, or it may say that it wants to terminate the connection later. So it may say that, okay, if you want to terminate the connection, then that is okay. I mean, it will acknowledge this packet that, okay, you do not want to send me the data, that is okay. Then it will just say, just send ACK. There is another way which says that server also wants to terminate the connection from this server to client way. So it will send the fin plus ACK packet, which means it will say that, okay, I also want to terminate the connection and I am acknowledging your previous packet. Then client will say okay, which means client will send the acknowledgement packet. Now this fin may or may not contain the data. If it is containing the data, then obviously it will consume the sequence number. If it is not containing the data, since it has to be acknowledged, right? See, earlier that was sin and now it is fin. So earlier that was sin plus ACK and ACK, right? Now see, these both are actually analogous. So earlier I was saying this sin has to consume one sequence number because that has to be acknowledged. Here also the same case, that this fin has to contain one sequence number because it has to be acknowledged, and this packet also has to contain one sequence number or has to consume one sequence number because this packet has to be acknowledged. So that's the case with fin and fin plus ACK. Now again, the ACK may or may not consume sequence number, depends on that this ACK is piggybacked or not. If it is not piggybacked, then that is okay because this ACK has not, like, will not be acknowledged again. So that is why it will not consume any sequence number. If it contains some data, then it will consume some sequence number, right? So that depends whether it is containing the data or not. Now the difference between this sin and this fin, or this sin plus ACK and fin plus ACK and ACK, is that earlier this sin packet cannot contain the data. I mean, it will just consume one imaginary byte, or it will just consume one sequence number because it has to be acknowledged. But here it may or may not contain the data. May or may not contain data. Earlier it cannot because this is the first packet, that's why it cannot contain the data. But here it may or may not. Similarly, it may or may not contain the data. Similarly, here also it may be piggybacked or may not be piggybacked, which means may or may not contain the data, right? But earlier it was cannot, it also cannot. Now in the last case also you can say may or may not. So see, this is just a connection establishment phase. That's why I'm saying the cannot. But once the connection is established, the data is being transferred, then you want to terminate the connection, then you will always say may or may not contain the data, right? These three packets may or may not contain the data, but these two packets cannot contain the data. That's the only difference. But yes, this will consume one sequence number. If it is containing data, then obviously it will consume more sequence number based on the data length. If it is not containing any sequence, any data, then it will just consume one sequence number. Similarly, this also, if it is contains some data, then it will obviously consume the sequence number based on the data length. Even if it is not consuming, or even if it is not containing any data, then also it will consume one sequence number because it has to be acknowledged. So that's the difference between this three-way handshake and this three-way handshake. So basically, in the connection termination, you may or may not contain the data, but in the connection establishment phase, you cannot contain the data because these are the first packets. So how can you contain the data? And in the last packet only, you may or may not contain the data, right? So suppose if I ask you that can this fin packet contain the data, then you will say yes. If I ask you, will this fin packet consume any sequence number, you will say always. Why? Because this fin has to be acknowledged. Will this consume sequence number? So if I ask you, will consume sequence number, Then you will say yes. Why? Because it has to be acknowledged. Similarly, it will consume one sequence number. Will it consume sequence number? Depends whether it is containing the data or not. Right? So this is three-way handshake. And four-way handshake is just analogous to three-way handshake, which just says that instead of sending this fin plus ACK together, server will say that okay, I do not want to terminate the connection, which means client says that okay, see, I want to terminate the connection, which means I want to send some fin packet. Server will say that see, that is okay, that you want to terminate the connection, but currently I do not want to terminate the connection. So the simple example is that suppose you want to sort some data. If you want to sort some data, you will send this array to the server. Then once you finish up ending, once you finish up sending the array to the server will say that that okay, I will respond back after the sorting. And meanwhile you will say that see, I do not have any data to send, so let me terminate the connection from my side. At least I let me be worry free, which means I'm terminating the connection from my side. So client will say that okay, please accept this fin packet. Server will say that okay, I'm accepting your fin packet, but currently I do not want to terminate the connection from my side, which means after some processing, maybe backend processing, server will again say that see, let me just finish this connection and let me just reply back with the data. So this fin packet will be containing the data. Most of the time it should contain the data. It may not contain the data, I mean depends on the application. But earlier I was having fin plus ACK, then I was having ACK. Then here I just divided this fin plus ACK into two parts. First ACK, then fin. So here between this ACK and fin, it may send data. It may send data, but there will not be any data transfer from client to server, because client has already said to the server that see, I want to terminate the connection. So please free up your any resources that you have, which means the server will be having some receiver window or some buffer. So client is saying to the server that see, I do not want to send any data, so you can free up your resources, and from my side, like I'm okay, you can allocate your resources to some other client, that is perfectly fine, but from my side, let's just free up your resources. I do not want to consume your any more resources. So that is advisable, right? I mean, if the client do not want to send any data, then it is good that client just says to server that okay, please terminate the connection from my side. Now server will respond back that okay, I have terminated the connection from your side, but I have some data to send. That is perfectly fine to the client. Then client, after sending the data, client will server will say that see, let me also terminate the connection. Client will say that okay, that is perfectly fine. So that is called four-way handshake. The difference between three-way handshake and four-way handshake is that here I have just divided the middle packet into two parts. That is the all difference that we have. Now if I ask you, will this contain the sequence number or not, then obviously it has to be acknowledged, then it has to consume one sequence number. And if it is containing the data, then obviously it will consume more sequence numbers. Will this consume the sequence number? No, this is just an ACK. It depends basically. ACK always depends. In case of ACK, if you remember earlier also, in case of ACK, it will always depend whether this ACK is piggybacked or this is just an ACK. So if it is piggybacked, then yes, it will consume the sequence number. If it is not piggybacked, then it will not consume the sequence number. So here also the same story. If it is consuming some data, then it will consume the sequence number. If it is not consuming the data, it will not consume the sequence number. Then obviously this is normal data transfer. Then after this fin, will this consume the sequence number? Yes, because this has to be acknowledgement. Will this consume more than one sequence number? Depends whether it is having data or not. If it is not having data, then one sequence number is done. I mean, one sequence number is enough. If it is containing the data, then depending on the data length, it will consume the sequence number. So this is the story of four-way handshake. Now I hope you got the difference between three-way and four-way handshake. So let me show you with the diagram that I have taken from the book. So this is the three-way handshake where I am just sending the fin packet. This is the fin packet where I am saying that this acknowledgement number is valid, which means like earlier whatever you have sent me, I am just acknowledging that. But yeah, this is the fin packet. Now I do not want to send any data. Now at this point, server will do what? Server will free up any resources that it has allocated as a receiver. So server is also sender and receiver, client is also sender and receiver, because TCP is full duplex. So server will free up the resources which server has as a receiver, right? Like the receiver window, allocated buffer, or anything anything that the server needs as a receiver. So it will free up the resources, and then server will say that okay, I also want to terminate the connection. So please accept this fin, because I want to terminate the connection, and I am also accepting your termination, which means I am sending the ACK. Then client will say okay, done, ACK. Right? This is three-way. In four-way, you will be doing what? In four-way, you will send fin, ACK, then normal data transfer. Then the data transfer, this is important, the data transfer should be from server to client only, right? The data transfer cannot be in this way now because the client has terminated the connection. So data transfer will be only this way. Okay. Now this once the data is transferred, it will send the fin packet and then it will send the ACK packet. And now I have written everything here, which means fin consumes one sequence number at least if it does not contain any data. If it contains data, then it consumes more sequence number. Fin plus ACK also consumes one sequence number if it does not contain data. If it contains the data, it will consume more sequence number. ACK, if it is piggyback, then it will consume the sequence number, otherwise it will not consume the sequence number. So this is three-way and four-way handshaking for the connection termination. And earlier we have studied the connection establishment phase. So now connection termination and connection establishment is over, which means like now you know that how to do the connection establishment in case of TCP and how to terminate the connection. Now let me take some examples, few scenarios, and using which I will try to more explain the how the data transfer is happening, how the connection is being established, and how the connection termination is happening. So I will take the examples. But before that, I want to show you that like these are just names. If you just want to remember, these are some names, names of states. Like during this phase of TCP, which is connection establishment and connection termination, there are some states from which the TCP goes. So earlier, like both client and server both are in the closed state, and this state is basically called closed. So these are the state names. So earlier this is the closed state, and once the client send the SYN, then the client, there is some state called SYN sent, the client goes to SYN sent state, and the server basically server is in the listen state, and server will send the SYN plus ACK and will go to the SYN received state, and then client will send the ACK packet, and the client will say that establishment state, and the server will also go to established state once it receives the ACK. Now in the established state, the data transfer will happen. Now once the client wants to terminate the connection, client will send the fin packet and will go to fin wait 1. So fin wait 1 is one state where client is waiting for the server to accept the fin packet. Once the server accepts the fin packet, which means the server sends the ACK packet, it will go to fin wait 2. Fin wait 2 is a state where the client is waiting for the server to finish the termination, right? So it will go to fin wait 2, and the server, once the server sends the acknowledgement, it will go to close wait state. So these are the state names, and once the server finishes the termination, it will go to the last ACK state, which means it is waiting for the last ACK. And once the client sends the last ACK, the connection is closed, and there is some time state state, which means that once you send the last ACK, it will wait for some time that we will talk about later, that is MSL time, so maximum segment lifetime. So it will wait for some time, maybe if this acknowledgement is lost, right? So it will send the ACK again if this acknowledgement is lost. Otherwise, if this acknowledgement is not lost, then the connection will be closed from both the sides. So these are just states. See here, I have written the state description, what does this state means, and here I have the state diagram, which means initially this is the state diagram of the client. Initially the client is the closed, then SYN sent, then established, then fin wait 1, fin wait 2, and then time wait. And this is the state diagram for the server, which means initially it is the closed, then server without any activity, server just go to the listen state, which means the server is on. So sometimes the server is off, sometimes the server is on. If the server is off, then it is in the closed state. If the server is ready to listen something, then it is in the listen state. And once it gets the SYN, the first SYN, it go to SYN received, and once it goes to SYN received, then it will send the SYN plus ACK. Once it sends the SYN plus ACK, it go to establishment state. See here, once it send the SYN plus ACK, and once it receive the ACK also, so it will go to the establishment state. So here I have the whole diagram, and then it will go to close wait state, which means this is the close wait state, which means once it sends the ACK, once it accept that okay, that I can send the data to the client, but client cannot send me the data. So this state is called close wait state, which means it is just waiting for the termination to close from its side, right? From the server side, the server is waiting for the termination connection to be terminated, and once it sends the fin packet, it will go to last ACK state, and then it will again go to the close state. So these are the states in which the TCP goes through the connection establishment phase and the data transfer, and then connection termination phase. So these are the set of states. So I hope this is pretty simple. You just need to understand that how the connection termination and connection establishment is happening. In between there are some states, and the state names are very clear, which means like this finwait 1 means like I have terminated from my side, I'm just waiting for the server to terminate. Finwait 2 means like I'm waiting for the server to terminate. Finwait 1 means I have terminated from my side. And this time wait means like I'm just waiting for some time for closing the connection. Close wait means like I can send the data, but client cannot send me the data, so I'm closely waiting for the connection to be terminated, which means I'm just waiting for my application process to finish the data transfer, and then I will terminate this connection. Now let's take some examples that how does the data transfer is happening in case of TCP. So before that, you need to understand how the acknowledgement behave in TCP. As I told you earlier, the acknowledgement is basically cumulative acknowledgement, which means that if I have multiple packets, then I will send the acknowledgement for multiple packets simultaneously. I mean, in one packet only, I will contain the sequence number that I am expecting to receive next, and this packet will be treated as a cumulative acknowledgement. So there are some rules using which we send this cumulative acknowledgement or this acknowledgement in TCP. Let me tell you some rules. Actually, these rules are, you do not need to buy hard those rules. I just want to show you that what is the practical implementation in today's internet, that how does acknowledgement behave. So let me show you some rules. So when you receive some packet, right? Like this is, let's suppose, receiver or server, and suppose it is receiving some packet. Then when you receive some packet, then there will be a question that if receiver has some data to send. See, once it receives some packet, then obviously it has to be this, like receiver has to send some acknowledgement. Now before sending the acknowledgement, if receiver has some data to send, then the receiver will obviously send the acknowledgement along with the data, because TCP has this facility in the header that acknowledgement can be piggybacked. So let me make a flow chart. So has receiver, or do receiver has some data to send. Let me just say like this: do receiver has some data. Or let me go to the next page so that I can write it very clearly. Do receiver has some data to send? If yes, if receiver has some data to send, then it will send the acknowledgement immediately. Then ACK will be sent immediately with data. Right? If no, which means receiver does not have any data to send, then what do you think? Should I send ACK immediately, or should I wait for some more packet? Because since it is cumulative acknowledgement, so why not to use this fact? Which means let me not just send the ACK for every packet. Let me wait for the more data. But how much data? So here I need to answer these questions. Which means for how many packets I need to wait, or should I be waiting for some time? So like that, like I need to answer these questions. Now the answer of this question is that if there are two packets, like if there are two packets that are not acknowledged yet, which means suppose if I receive one packet, I do not have any data to send, okay, which means that I just need to send only acknowledgement. Now should I send the acknowledgement right away, or should I wait for some time, or should I wait for some packets? I hope you got it. So these are the three questions. Should I send right away? Let me write these three questions here itself. So first question is that, I mean, these three questions are basically same, not just three questions, just a one question I'm writing in different form. Should we send ACK right away? See, this is the case where I do not have any data to send. I just need ACK to send. Second thing is that should we wait? V means receiver, okay? Should we wait for some time? Third thing is that should we wait for some segments maybe? Should we wait for some segments? Which means should I be waiting for some time? Should I be sending ACK immediately, or should I be waiting for some segments? These are the 2-3 questions which are almost same. I mean, these three questions are same, which we need to answer at this point in time. So what do you think? What is what is the efficient strategy? I mean, nothing is wrong here, which means you may send the ACK immediately, but it is not very efficient. Which means I am not utilizing the fact that ACK are cumulative. So I think this is not a good idea to send the ACK immediately for every packet, right? So should we wait for some time or should we wait for some segment? Basically both, which means whichever is earlier. So generally in the practical implementation, I'm telling you, in the this is if you want to talk in theory, then in theory you can have anything. But I'm talking in terms of practical implementation. Then that today's TCP versions are implementing. So they wait for some time and they wait for two segments, only two segments, which means if one segment is unacknowledged, that is okay. But once they receive two segments which are unacknowledged, so it immediately sends the acknowledgement. Okay, so one is that they wait for two segments. Second is that suppose one segment has come but second segment is not coming at all. Maybe second segment is taking too long to come, so obviously it will not wait for that long, so it will just wait for some timer. That is called ACK timer. So after ACK timer, it will send the acknowledgement. So basically, it depends whether you are getting two segments first or your ACK timer is getting expired first, right? So it depends. Now, I hope you got the idea. Now, suppose here is little twist because TCP is selective repeat protocol. TCP implements selective repeat protocol, which means TCP accept out of order packet also. So what they have done here at this point in time, which means you do not have any data to send, but you have ACK to send. So at this point in time, they check whether the segment that is coming to you is in order or out of order. So let me just write in the flow diagram or flow chart. In order packet, if you have received in order packet, yes, or out of order packet, no, right? If you have received in order packet or out of order packet. So there are two cases here. If you have not received out of order packet, then which means you have not received in order packet, which means you have received out of order packet. Out of order packet. Then they send ACK immediately. Send ACK immediately. Why? Because if you are receiving, just think about this, if you are receiving, you have already received this, now instead of receiving this, like because of some data loss, you are receiving this packet directly, this packet, the third one, you are receiving this one directly. Since this is selective repeat, so it is having some buffer to store this packet. Now instead of waiting for two segments to come, it immediately sends the acknowledgement by saying that, see, I am waiting for this packet, right? So this just help us for the fast transmission for the missing packet. You are getting it? See, suppose this is your receiving buffer. You have got suppose this packet, and now suddenly you have also got this packet. Just now you have got this packet, right? Now these two packets are acknowledged. Now instead of waiting one more packet or for the timer to expire, it sends immediately acknowledgement for the third packet. Let's suppose this is sequence number 5000 something. Okay, it will say ACK 5000, which means it is saying that, see, I am expecting 5000 ACK sequence number. So it does not wait for the timer or for the two segments in case if the packet is out of order. It just helps TCP to transmit the missing packet or the lost segment fast. So here, if you have the out of order packet, then it sends immediately. It sends the ACK immediately, right? If you do not have out of order packet, then the rule that I just told you is applicable, which means it either waits for timer or for two segments to come. So this is the complete flow diagram or flow chart using which TCP sends the acknowledgement. See, first thing is that acknowledgement is cumulative. Second thing is that whether you should be sending the acknowledgement immediately or you should be sending after some time. It depends whether you got the in order packet or out of order packet. If you got the out of order packet, then always send acknowledgement immediately so that it helps TCP to send the missing packet for the it helps TCP for the fast transmission of the missing packet. If your packet is in order, then the rule that I told you, whether you are waiting for some time, which is ACK time, or you are waiting for two segments to come, these two rules are applicable, and whichever is expires first. Which means if you get two segments within the ACK timer, then you will send the ACK. If you are getting two segments and before the ACK timer, which means the ACK timer is getting expired first, then it means you need to send the ACK after the ACK timer expires. So these are the rules that are applicable. So again, you do not need to remember this flowchart. I just told you whatever is there in the practical implementation. You just need to remember one thing, which is that TCP uses cumulative acknowledgement. Okay, just stick to that. The TCP uses cumulative acknowledgement. How it sends the acknowledgement is not of big deal. I mean, like you should not be worrying about whether it has data to send, then it sends the acknowledgement immediately or not. I mean, these are the practical implementation to have the better efficiency, and everything is leading to the efficient implementation, right? See, it has data to send, so why not to send the acknowledgement immediately? Makes sense, right? Here it makes sense. If the data is in order, then obviously it should make sense that that it waits for some time or maybe some segment. If data is out of order, then it makes sense to send the acknowledgement immediately because it helps the TCP for the fast retransmission of lost packet. So everything is making sense to improve the efficiency in the practical implementation. Okay. Now let's move to the most awaited thing, which is how to actually send the packet in some cases. Which means, like, I will take some of the examples. Like I will take five, 6 examples, and using which I will show you how the transmission is happening. So let's take this as an example. Now suppose this client is sending some packet. Now see, all the examples that I have taken is from Forogen book, and the rules that I'm taking, that I just told you, are from Forogen book. So I will be following only one implementation, which is this, which means I will be following this implementation. So now these things depends on the implementation, and the Forogen book is having the practical implementation, so I will be sticking to this implementation, but you do not need to remember this, right? So see, this client is sending some packet. Now suppose server has some data to send. Now if it has some data to send, then it will immediately send the acknowledgement along with the data. That is done, right? Now once it receives some acknowledgement, no, once it receives some data, then it will wait for some timer if it does not have data to send. Suppose at this point in time client does not have any data to send, then it will either wait for some timer or the second packet to come. Suppose the second packet is not coming, then it will wait for some time, and it will basically send the acknowledgement after some time, which means the ACK timer got expired here. Now here suppose that server has some data to send, and server is sending the data back to back. So at once first packet is received by the client, which means this packet, client will start its timer, ACK timer, to send the ACK packet. But once the client receive two packets from the server, and both of them are unacknowledged packet, then client will immediately send the acknowledgement, right? So before waiting for the timeout to expire, which is, let's suppose timeout is 500 milliseconds. So before waiting for the timer 500 millisecond, it will stop the timer before the 500 millisecond, and it will send the acknowledgement. So this is very normal operation. I hope you got it. Now let's talk about some of the operations where I will be receiving out of order packet, and I will be receiving some I may need to retransmit some packet because of the lost packet or these things. So let's talk about some interesting cases. Now before that, let me tell you what happens if there is a packet that is out of order. I mean, that is very obvious because the TCP uses the selective repeat protocol, which means it will store the packet, but still I have written in the slide. So data may arrive out of order and temporarily stored in the receiving TCP. So because TCP is using selective repeat, that is why it should be obvious. But TCP guarantees that no out of order are delivered to the process, which means TCP is a reliable protocol, and it guarantees that whenever it is delivering the data to the application layer, then this data is reliable, which means the data is in order. So TCP may store the out of order packet, but the delivery is always in order. Okay. So I hope you got it. Now when we do the retransmission, which means whenever we are sending the data, if the data is lost, in what case we do the retransmission? What are the rules that we need to follow for the retransmission? So let's just see this. See, suppose you send some packet and this packet is lost. Obviously you need to retransmit this packet, but you may have sent multiple packets and one of them is lost. Obviously you need to retransmit that packet. Then one rule that is immediately coming to our mind is that why not to start a timer, and once the timer expires and the acknowledgement of this is not received, then you will retransmit this packet again, right? That is perfectly fine. So this is called retransmission after timeout. Retransmission after timeout. Now There is another thing that is called retransmission after 3 duplicate ACKs, which means suppose this packet is lost, but these packets are not lost, which means this packet is lost and these packets have been received by the receiver. So what will receiver do in this case? Receiver will send the ACK. Why? Why? I mean, if I just recall you about the implementation that we are following, so receiver has to send the ACK? Because receiver has just got some out of order packet, right? Because receiver was waiting for this packet and this packet is not received. Receiver just got this packet, maybe this packet and this packet. So receiver has got out of order packet. That's why receiver has to send ACK immediately. So receiver will send ACK here, ACK here, ACK here. Because receiver is getting these packets as an out of order packet. So receiver will send ACK here, ACK here, ACK here. In these three cases, receiver will send the ACK. So what does this mean? I mean, this ACK, so suppose this is ACK for 5,000 and this ACK is for 5,000 because receiver is waiting for the missing packet, which is 5,000 packet. So this sequence number is 5,000. The first byte is 5,000, which means this sequence number was 5,000, which has been lost. So receiver will again and again say that, okay, I'm waiting for 5,000, I'm waiting for 5,000, I'm waiting for 5,000. Now there are a couple of things that are happening here, that sender at the sender side, sender will get to know two things. Obviously, sender will get to know that, see, the ACK for 5,000, like sequence number for 5,000 packet, this packet has been lost because it is still asking for 5,000 packet, then again asking for 5,000 packet, then again asking for 5,000 packet. Then sender will get to know that, yes, I need to resend the 5,000 packet, right? A sequence number with the 5,000, I need to resend. Sender will get to know definitely this. One more thing sender will get to know. Can you guess it? Why? What is that another thing? Sender will get to know that, see, my 5,000 number packet has been lost, that I completely agree, but all of the other packets that I have sent, they must have been received. Then only I am getting the acknowledgement for 5,000 again and again. See, why I am getting the acknowledgement for 5,000? Because this packet has been received. Why I am getting this acknowledgement again? Because this packet has been received. Why I am getting this acknowledgement again? Because this packet has been received. So sender will get to know not only that I have to retransmit the 5,000 number packet, it will also get to know that other packets has been received, right? So what is the difference between this and this? So see, there are, like, in two cases there could be retransmission. One is that timeout. Another one is that if I am getting duplicate ACKs. So this 3 is some magic number, you can say, some fictional number that we have taken. There is no theory like why we are taking 3. I mean, there is no mathematical justification. This is just the heuristic that we need to just consider 3 ACKs, which means even if we are getting, if we wait for 5 ACKs, 4 ACKs, then also it will work. But 3 is some good heuristic, which means it is neither too early nor too late. Okay, so that's why I have taken, or that's why the most of the implementation takes the 3 ACKs. So what does the 3 ACK means? That I have lost, like the channel has lost this 5,000 packet, but channel has also delivered other packets. That's why I'm receiving these acknowledgement. So I need to send the 5,000 packet, but I'm happy that other packets has been received. That's what the 3 ACK lost means. Suppose that timeout is happening here, and I have received 3 ACKs earlier. Then isn't it good? Which means I should not be delaying the retransmission. Am I not doing the retransmission fast? So in this earlier case, suppose I have not got the 3 ACKs and the timeout has been expired after some time. So I will anyway send the packet. So retransmission will anyway happen. But am I doing the retransmission early or am I doing the retransmission at the timeout? That's the only question. I mean, retransmission will happen in both of the cases, but am I doing the retransmission after timeout or I'm doing the retransmission before timeout? So if I have received 3 ACKs, then I'm doing the retransmission before timeout, because this is clearly a sign that I have lost or channel has lost the packet with the sequence number 5,000. This is clearly a sign. So why should I wait for the timeout for packet number 5,000 to get expired? Right? I should not wait for the timeout to expire. So I will send the 5,000 packet number early. So that's called fast retransmission. This is called fast retransmission. And this is called retransmission after timeout. So in the fast retransmission, basically I'm sure that the other packets has been delivered, which means that the congestion or the traffic on the network is not that much severe. Why? Because if only one packet has been lost, not the other packets are being lost, which means the congestion is not that much serious that that I should be very worried about, right? If there is a timeout, which means I am not receiving 3 ACKs, and now the timer is getting expired. It does not only mean that these 3 packets has been lost. It also means that the congestion in the network is very severe, which means not only just one packet has been lost, 3 other packets has also been lost, probably. I mean, this timeout is one indication that the congestion in the channel is very serious, and this 3 ACK is an indication that, see, just one of the packet has been lost, so do not worry much. Okay, so we will talk about the congestion control in the next video, but here I am just giving you an intuition that this 3 ACK means that congestion is not serious, but timeout means that congestion is serious. If I am not receiving 3 ACKs, I am just receiving the timeout. It means that not just the first packet is lost, the other packets must have also been lost, because I am not receiving the ACKs. That means the other packets must have been lost. So congestion is serious here. Now there are obviously arguments that the congestion is only serious in one side, which means it may be or maybe delivering all the packets, but all the ACKs are lost. That may be also the case. But at least the congestion is serious in at least one of the direction, either in this direction or in this direction. But if I am receiving 3 ACKs, then it means congestion is not serious, because I have delivered 3 packets successfully, and receiver is also able to send me 3 ACKs successfully. This means congestion is not serious. So that's how we do the retransmission. I hope you got it right. So this is out of order segment and retransmission. Now till now we have built a very strong foundation about the TCP, which means I have told you how to do TCP connection management. I have told you how to do the ACKs, which means how to send the ACKs, whether the ACK is cumulative or not, or how to store out of order packets, how to retransmit. So we have basically, in the theory we have answered all the questions. Now is the time for taking some examples to justify these points. So let's take some examples using which I will be like more clearly able to explain these points. So let's take this example. In this example, I want to show you the out of order packet. So what happens if the packet is delivered out of order? Suppose you send some packet and then you send 2 packets, then it is sending ACK. Okay, don't worry about like why I'm sending ACK at this point. I know that you know that why I'm sending ACK, because the 2 packets has been delivered, that's why you are sending ACK. But let's not worry about it. Okay, my point here is to explain you that what happens if you receive the out of order packet. Suppose this packet is lost. This packet is lost, and then you send this packet, I mean the next packet, then the receiver or the server will send the ACK and also will store this packet. Now just see here, the packet from 5 till 600 has been received. Now packet till 700 has been received. Now receiver is waiting for the packet that start with the 701, right? 701. So receiver is waiting for the packet that start with the 701 or the sequence number with the 701. But the receiver has just got the packet that start with 801. So what it will do? It will obviously store the packet, but this is an out of order packet. So receiver will say that, okay, please send me 701 only. So this acknowledgement, just see here, this acknowledgement is for 701, not for 801. Why? Because receiver is still waiting for the 701. If this acknowledgement is for 801, which means like it says that 901 because this packet has been received, then this will be completely wrong because the ACK is cumulative. So that's why I cannot even send the acknowledgement for 901, right? So receiver will say that I am still waiting for 701, and once this has been reached to the server or to the client, then this packet will be resent either after the timeout. So see here, this packet is getting the timeout either after the timeout or after the 3 ACKs. So in this case, after the timeout. I mean, it depends which situation is occurring first. So I have just got 2 ACKs, not 3 ACKs. So I'm sending the packet after the timeout. So once this packet gets delivered, now I'm sending the ACK for 901. That's how it is happening, right? Now this is the example where one of the packet got lost. Now let's see the another example. In this example, I want to show you what if there are 3 ACKs that we are getting. So suppose that this packet is lost, but in between that I have got 3 duplicate ACKs. Then before the timeout is basically stopping here for this 301 to 400 packet. Before the timeout only I am sending the packet. That is perfectly fine, right? So this is retransmission after 3 duplicate ACKs, and this is retransmission after the timeout. Okay, let me write here retransmission after timeout. This is retransmission after 3 duplicate ACKs, right? Now let's see this fourth example. In this example, what we are doing, we are sending some packets, but the ACK is lost, right? This acknowledgement is lost, and still let's suppose I have sent some packet, which means I have not received the ACK till now, but I have received the ACK directly for 901, which is perfectly fine, which means this 901 ACK is saying that all the packets has been received. So this is the example where I want to show you that how this cumulative acknowledgement is helping us. If even if the one of the acknowledgement is getting lost, I am still able to get the acknowledgement or still able to get the confirmation from other ACKs that all the packets has been received. This does not only tell me that packet number, some packet like packet number, last packet has been received. It also tells me that all the packets till the last packet has been received, because this is the cumulative acknowledgement, right? So using this example, I just want to show you that how cumulative acknowledgement is helping us. Now let's take the next example. Here, this I think. Yeah, sorry. So I think this example is same as this example. So this is the same example. I think wrongly pasted the same example. So let's take this next example. Now here I am sending 2 packets, and then this acknowledgement is lost. Now after the timeout, obviously this packet will get again retransmitted, right? So that's very simple example, and then it is getting the ACK. See, you do not need to remember these rules. You just have your common sense that what's going to happen in the cumulative acknowledgement case. Right? I hope you got it. So in the next video, we will be discussing about the congestion control.